Hi, everyone. I'm Mike Richter. I am an Azure technical evangelist at Microsoft. I've been at Microsoft for a total of 9.5 years. I did take 2 years off in the middle there to go do consulting. I was a software engineer for the first 7 years at Microsoft, and for the last 2.5 years, I've been a technical evangelist. I work primarily with software companies who are building applications on our cloud platform. I worked about 24 of them over the past 2.5 years. Before then, I was a software engineer. Before Microsoft, I was a software engineer for a long time. And so that's basically who I am. Today, I'm going to talk to you about designing Azure Resource Manager networking. I just delivered this talk downstairs, and I went way over, so I'm going to go a little bit faster so we can get to all the content and I take all your questions. So there'll be some content that I'm just going to not mention as we go through, but all these slides are available, and so anything that you want to learn about. I also have links on every page for documentation for all the content. So even if I don't get to it during the presentation, you'll still have it, and then if there's something I'm missing, you can ask me a question afterwards. So this is the all-up presentation, the all-up exam goals. So we're going to be hitting the first two for networking. One thing that I wanted to talk about for this slide that actually helped me when I passed the exams. I took the exams 2 years ago. But one thing that helped me pass one of the exams was the mental cheat sheet, right? Where there are a lot of times, there are a lot of tables that you're asked to memorize or asked for, like, you know, given these requirements, do I need a premium tier or do I need the standard tier, right? Which is the most cost effective? And then you're like, damn, I wish I knew if it was 50 gigabytes or 100 gigabytes, what the difference was. So, so there are a lot of tables. There are some key tables. If you just get, what I did was I just wrote them down constantly in a notepad. I just kept on writing them down, so it became muscle memory. I wasn't even aware what I was writing after I did it, like hundreds of times, literally hundreds of times. And then when I got to the exam, I wrote them down right on the cheat sheet, and that way I didn't have to think about it. And if that helps you get 1 or 2 questions right that should have been, you know, easy points if you had memorized that detail, you know, that could make the difference in passing the exam. So that's just one tidbit. Here's the agenda for this talk that I'm going to be doing. We've got networking. Networking is kind of the foundation for running IaaS in Azure. So networking and network security groups are the access control to your VMs running in networking. We'll talk about how to create hybrid connections between an Azure virtual network and your network on premises or another virtual network in our cloud or another cloud. We'll explain that. And then we'll talk about networking services, what services we can use with our applications like load balancers and our app gateway as well. And then as I go through, you'll see some red text. That is kind of the important. There's a lot of data, there's a lot of stuff, but the red text is something that comes up often, right? We're going to be looking at a lot of content, and if you're kind of new to Azure, as we go through this, you may not know, you know, there's all these details. What's kind of important for me to know if I'm an Azure architect, right? So the red is something that I feel like, you know, every Azure architect should know these things, okay? You should know, you know, as much as you can, but I think the red stuff comes up a lot. All right, so jump right in, talk about virtual networks. So virtual networks are where our VMs in Azure live. They are software-defined networks. The important thing to know about networks, VNets, are that they are isolated. So I create a VNet in the East US region, and it's isolated. I have no, it has no connection to any other VNet unless I enable that, right? So we have thousands of customers, hundreds of thousands of customers. All their VNets are completely isolated from each other, right? And then we have, by some measures, the most compliant public cloud. So all the security, privacy protections are there. We make sure of that. So you can feel confident that it is protected out of the gate. Another important thing to know about our VNets is that VMs running in the VNets have up to 500,000 TCP connections. So when you're thinking about the applications you build, if you're saying we're going to get 2 million concurrent users, well, you might need 4 VMs to handle that. So that's something else to think about All the VNets are connected to the internet by default. So if I deploy a VM into an Azure VNet, it can reach out to the internet automatically. I don't have to do anything to enable that. I of course, can change that with a network security group, which we'll talk about next. But by default, all the VMs can talk to each other, regardless of what subnet they're in, and they could also talk to the internet. The VNets are only inside one Azure region. That's important to know. And you can assign the public IP address range spaces, or you can also use private IP address ranges for your VNet. Some ranges are not allowed. These two tables kind of show you the properties that define a VNet and a subnet inside that VNet. So like I said, address space, you can define, right, by default in the portal, we'll show you 10.0.0.0.0, WAC 16. And then also, you can use Azure's DNS. So if you want your VMs in your VNet to talk to each other by host name, you can use our DNS. Or you could bring your own DNS, and we'll see why you might want to do that later. And then inside a subnet, pretty similar. The address prefix for the subnet is a subset of your address for the entire VNet. And you can also assign a network security group to your VNet, and that's important. So a network security group, which we'll talk about right after this, is how you decide who can do what with your VMs, who can access them, what traffic you'll allow in and out. So that can be either associated with a VM itself, or it's associated with a network security group, right? And so the idea here is, let's say I have some front-end web servers. I want to allow port 443 for all those front-end web servers, right? I can put them all in a subnet that has that rule. Allow from the internet 443, that's it. But let's say in there, I want to have a jump box, so I can go onto any of those web servers and do something. I could put in that subnet a VM, and on that VM alone, I could have its own network security group. And on there, I allow port 22, so I can SSH in, let's say, right? So network security groups are either applied to a subnet or to a VM directly. The route table, you could also, we'll talk about that later when we talk about user-defined routes. You can create your own route. So if you want all your traffic to flow through a virtual appliance, let's say, or to tunnel back to your on-premises environment, you can build routes. So network security groups, this is the other half. There's virtual networks and then network security groups. So when you see, also, just a quick note, when you see in my deck here, you'll see something like 100 WAC 400 network security groups per region per subscription. The 100 is our soft limit, right? So Azure has a bunch of soft limits for all our services have soft limits, and then we have like a real hard limit. So to go beyond 100 network security groups, you'd have to open up an Azure support request through the portal. It's pretty easy, and then request more network security groups. So anytime you see throughout the presentation here that kind of notation, that's what it means. It's soft limit, WAC, hard limit. And we have those limits to protect you and to protect us. To protect you so that you don't accidentally spin up a million VMs, right, through automation, through a fat fingering a zero or something. And also protects us, because if you really do want to spin up a million VMs, we want to know about it so we could do our own capacity planning. So that's why we want the support request. So that's the idea behind that. So network security groups. You can have 100 per region per sub. You can have rules, up to 200 rules on the network security group. The rules are allow or deny traffic, inbound or outbound. Actually, the next slide goes more into detail about that. Important thing to know is that we have something called default tags for IP address ranges. So let's say you want to allow traffic in from the internet. You don't have to put in, 0.0.0. You don't have to do that. You can just say, I want to allow internet traffic, and all internet traffic will come in. The same for the Azure load balancer. If I only want traffic to come in through the Azure load balancer, you can just choose Azure load balancer in your rule, or the virtual network. I only want the VMs in the subnet to get traffic from the virtual network. So this makes it easier than having to kind of write IP, the CIDR notation yourself inside. You can just choose these kind of 3 broad tags. And then every network security group that gets created comes with some default rules. By default, when I create a network security group and I apply it to a subnet, all of the VMs in that subnet can talk to each other, and they can talk to other VMs and other subnets in the same virtual network. By default, that's allowed. All the VNets can communicate across subnets, all within a virtual network. Also, by default, we allow traffic from an Azure load balancer. And then we deny everything else. So these are rules that are turned on by default. You can override these rules if you want, but that's the inbound and the outbound, the same thing. I can go talk to any VNet I want. I can go talk to the internet, and that's it, right? I guess that's everything, right? So, so those come in, and you can overwrite that. And so looking at what a network security group rule is, these are all the different components of a network security group, right? You choose your protocol, your source, where is the request coming from, what port, what address prefix, what port is it going to, what address prefix is it going to, is it inbound or outbound, the priority. So the priority is the number that you would use to create what rules overwrite each other. So the lower the number, the higher the priority, right? So our default rules are down at like priority 65,000 or something, right? So if you want to overwrite any of our rules, you just write your rule at rule 100, and that will overwrite. So the lower the number, the higher the priority. All right, so that's networks and network security groups. I know I ran through that. Any questions? I'm going to move on to the hybrid section, but just any questions? Okay. Cool. So hybrid is all about how do we connect our Azure virtual network to our on-premises network. And so there are a few ways we do that. There is, we have VPNs that you can create, point to site for creating an individual that gives you a client that you install on your computer, and you can connect into a virtual network in Azure over VPN, site to site, where you take your data center and attach it to Azure, and they can kind of communicate across the directly, both networks via site to site. And then we've got ExpressRoute, which is a direct connection, because VPN goes over the internet, but ExpressRoute is a direct connection into Azure. So whenever we create a hybrid network, we need kind of five, at a high level, from an architecture perspective, we need 5 things to do that. We need our VNet in Azure, right? We need a gateway subnet in Azure. That's where all of the gateway traffic to wherever else we're going to be communicating will go through. And then we need a gateway. So a gateway is a device on the Azure side that gets created for handling the traffic. It needs a public IP address so that it can be paired with some other external location. Then you need something called a local gateway. And the local gateway is a representation of whatever, let's say, your local network, right? Let's say the network in your office is a local network, right? I don't like the word local. It should be like something like external. And anything that's external to Azure, that's the local network. And you'll need a public IP address there. So if I've got my on-premises environment and I have a VPN device, I need a public IP address there, and I'll represent that in my setup on Azure with the local gateway. And then I need the connection with a shared key to connect the two, right? And all of this can be set up in Azure with automation. This is simple, because I've had partners ask me, hey, do I have to set up a request if I want to create a VPN from our environment to Azure? No, this is all could be done with automation. And in my first lab for this, we set it all up with an Azure ARM template. It deploys all the resources, and that's between 2 VNets in Azure, one in the East US and one in the West US. So this could all be automated. You can't use Azure automation for your on-premises environment for setting that up. You have to still do that through whatever process. But once it's set up and you've got its public IP address and the shared key set up, setting up the Azure side is easy. So you can build a VPN to your environment in minutes on the Azure side. All right. So there's 2 kinds of VPN gateways. We've got policy-based and route-based. Policy-based is basically static routing, and route-based is dynamic routing, depending on your needs. There are some limitations, we'll see on the next slide. There are some limitations depending on what VPN type you use. Then we also have our SKUs that talk about what the performance levels of our different VPN gateways are, right? So just be aware of these when you're making decisions, based on what you need for your environment. So then we've got, this table just kind of also gives you an understanding of the capabilities based on what you choose. Like I said, policy-based VPN is not supported with point-to-site. I don't think it's supported, we don't have ExpressRoute on here yet, but this, this is another table that gives you an overview of what capabilities are available depending on how you configure your VPNs. To connect to on-premises, you can use ExpressRoute or site-to-site VPN. Like I said, site-to-site goes for the internet, so there's latency. You don't get a kind of guaranteed throughput that you do with ExpressRoute. ExpressRoute is a direct connection, and we'll talk in a minute about how you create an ExpressRoute connection from Azure to your data center. But you could also use them in a failover. So you could have site-to-site and ExpressRoute in the same VNet so that if there's an outage from your carrier for the ExpressRoute, you can fail over to your VPN. ExpressRoute is more than just your virtual networks also. I think it's important to understand as an Azure architect that you can peer your on-premises environment not just to Azure virtual networks, but you can peer to Azure public services, right? So there is, in the routers on the Azure side, we're aware of our public IP address ranges for all our PaaS services as well. So if you're using Azure Web Apps or using Cosmos DB or SQL DB, all of the traffic to those resources will go through or can go through your ExpressRoute connection. So you'll get the performance and the security of having that all kind of go through that direct connection into Azure. Of course, you can connect to your own virtual networks, and if you're an Office 365 customer, you can use ExpressRoute for connecting privately to those resources too. Then, how do I connect to ExpressRoute? These are kind of three high-level options. If you're hosted, if your data center, your networks are in one of our cloud exchange co-location partners like Equinix, then you can connect directly from that cage in that data center up into Azure, right? They could wire that, and that's like a physical connection to Azure. If you're not in one of those partners, but I guess if you're close by, they can run a line from where you're hosted to one of those partners to get you into Azure. Or if you're not, there's another option, which is through your ISP, right? So whoever provides your wide area nexus, your wide area network for connecting all your offices, you can have Azure appear as another node in that wide area network. So, so we're talking about the what and the why. The how is a little more complicated, but for the architecture exam, we need to know this. A little bit more about ExpressRoute. It does have a nice SLA for it, because there's two circuits actually inside, so that there's redundancy in case one of them goes down. You can get the minimum circuit size 50 megabytes, the maximum is 10 gigabytes. You can attach up to 10 VNets per circuit. There's two plans. There's metered and unlimited. So metered, you pay for all of the outgoing traffic from Azure. Unlimited, you don't. Unlimited is more expensive. So you have to look at the details. You have to understand what your workload is and decide what's going to be more cost effective. And that link has the information around pricing and an FAQ to help you figure that out. There's also a premium add-on for ExpressRoute, which gives you access to more. You can connect to more VNets. You can create more private peering routes. And then these videos actually just were posted in the past few weeks. These are Scott Hanselman's Azure Fridays, where he talks to the ExpressRoute PM, and they go over this really well. They're like 10 minutes each, but they give you a really good architectural overview of ExpressRoute. And then this last slide for hybrid is just another way to think about, all right, so we've talked about all these different ways to kind of connect my Azure virtual network to an on-premises network, but which one should I choose? Which one makes sense? So here's my workloads right? And here's kind of a way to decide, do I need point to site? Do I need site to site, or ExpressRoute? So, all right, that's it for hybrid. Any questions? No, okay. So network services. So let's jump into this. So I'm going to talk about our load balancer, our application gateway, and traffic manager, all at a high level kind of load balancers, routers for traffic. Load balancers is our kind of entry level option here. It's free to use. It's kind of a no frills layer 4 load balancer. It uses this hash distribution model, which lets you basically say inside of a transport session, you can have the same VM respond to all of the requests based on these 5 components here. So this is useful for like RDP, where you first make a connection to the VM with TCP, and then the rest of the request happens with UDP. That's primarily what that is for. I think we do media streaming. It's a similar case, right? But there's no session affinity. So if I'm building a website, so I'm using load balancer, the website traffic can get handled by any of these VMs in the backend pool. Not always the same one. There's no affinity, no session or cookie-based affinity. In application gateway, which we'll talk about next, that's where you have those more layer 7 type networking capabilities. So this is kind of a bare bones load balancer. You do get port forwarding, so if the traffic is coming in on port 443 or port 80, but my application exposes that on port 8080, right? I can translate from port 80 to port 8080. I have a NAT capability, so if I have 5 VMs that are load balanced, but I want to SSH into each one individually, I can give them each publicly. I can give them one, 2201, 2202, 2203. That will all get natted to port 22, so I can SSH into all those machines individually. And then there are probes. I can build a guest probe is for our PaaS services, so I won't get into that now. But HTTP custom probe, if I want to create a web page that my load balancer pings to see if the service is healthy, I can create a custom web page. If it returns 200, we're good. Anything else, I think, is bad. So if you want to gracefully kind of remove a VM from the backend pool because you're going to take it down, or you're bringing up new VMs with a new release on it, you can kind of build that in. Or you can just have TCP custom probe where you're just pinging as long as it gets a response. We're good. So you have some flexibility there. We have public load balancers, which get a public IP address, and internal load balancers. So you can see this is a kind of architecture that you could build with these load balancers. Like I said, and load balancing doesn't cost anything in Azure for this service. And then the outbound traffic and the source nets. So if I've got all these VMs and the VMs make requests, then they're behind a load balancer and they make requests out to the internet, those requests will look like they're coming from the public IP address of that load balancer. Unless I attach a public IP address to that VM, then the traffic will come from that public IP address. Does that make sense? So. All right, so that's our load balancer. Now the application gateway. Actually, one distinction to go just on load balancer is in load balancer I can load balance across any kind of TCP or UDP protocol and any port. With the application gateway, I can load balance, but only HTTP and HTTPS. So it's meant for web applications. Application gateway. You do get cookie-based session affinity if you want it. So multiple requests across a user's session can be serviced by the same VM if you are using, if you're using a stateless application or for whatever reason you need to do that. Web application firewall is built in. So if you say for compliance reasons we need to make sure that we're behind web application firewall, because, well, for compliance reasons, we have open source one that's built in. You can turn on. It has a default set of rules for the OWASP top 10, but you can configure that. There's also SSL offload, so you can have your SSL associated with the app gateway, and then all the traffic from the app gateway to your VMs will be unsecured, so so your VMs don't have to do the SSL offload themselves. But if you do need to have the data protected all the way, encrypted all the way to the VMs, you can do end-to-end SSL. And what will happen there is you've got the SSL certificate associated with the app gateway. The app gateway temporarily, in memory, decrypts the traffic, inspects it, because you can write rules based on the domain, based on the URL, to route it to different backend pools. So it'll temporarily decrypt, see where you're going, route you, and then using a certificate will re-encrypt the traffic. Your VMs have to have that certificate installed as well, but you can achieve kind of an end-to-end SSL and still use the capabilities of App Gateway. And then you can route the content based on the path of the URL, and you can support multiple sites with one App Gateway. So I can have www.a.com, .b.com. I have up to 20 of those. And then because this is a paid service, it comes in 3 different flavors: small, medium, and large, right? And then on here you'll see decisions to make on do we need a small one, medium, depending on your traffic and how big your pages are, right? You can decide what you need, and then you could have up to 10 instances of the gateway each, right? So you have 5 small instances, 2 medium instances, 1 large instance. You're going to have to do some, load tests to see exactly what you need here. Okay. The next load balancer service we have is Traffic Manager. Traffic Manager actually operates at the DNS level. It's not an Azure service per se. It is, but there's no kind of infrastructure. It's all at DNS. And what this lets you do is route requests between different Azure regions. So I've got my website, www.mike.com, and I may have 3 different regions. I got mike.eu for Europe, mike.na for North America, and mike.asia, right? And so using DNS and the routing rules, we can point you, the traffic manager can make a decision on which of those deployments or endpoints we're going to push you to, right? So the routing rules are priority, right? So that's if you've got an active-passive architecture where you say, I want all my traffic to go here, but if there's an outage here, here's my secondary. That's what you'd use priority for. Weighted is, I want 20% of my traffic to go here, 30% of my traffic to go here. That might be useful if you're doing, let's say, canary releases, or you want to deploy straight to production, and you say, I only want 10% of my traffic to get this new production code, and as long as we're good and I'm not seeing it all crash, I'll slowly increase that weighting and change the weighting ratios. You can use that. Performance is, again, in that scenario where I've got North America, Europe, and Asia, I want my customers in Tokyo to go to Asia. I want my customers in Canada to go to North America. That's performance-based. And then geographic-based is if I want to get even more focused and I want to say, I want customers from these 3 countries, US, Mexico, North America, to go here, and I want to go to the US, and I want people from South American countries like Argentina and Brazil and Uruguay to go to my Brazil data center, because at Uruguay, or Venezuela, maybe they're going to go to the North America, depending on the routing. But for geopolitical reasons, I need to keep all the data in the right place. I can get more fine-tuned with the geographic routing. And then I can, so just the endpoints. So once I've decided where you're going to go, well, where can those endpoints be? The endpoint could be your an Azure load balancer, an Azure VM, any public IP address in Azure. It could be a web app, one of our PaaS services, an Azure web app. You can nest it. You can point to another traffic manager and build a complicated routing setup. Or external. So if you say, I want to load balance between my on-prem and in Azure, I've got, I can do that too. As long as you've got a public IP address. For external, we don't care where it's hosted. So, yes? Yeah, so when I say if it's, the question, I think is if I've got customers in the East Coast and US and I have one endpoint in North America, where do they go to? Well, that endpoint has to live somewhere in North America. It's either going to live in one of our North American data centers. So in Canada, we have 2. In the US, we have a dozen or so, right? So you would say, I'm going to deploy to East US. So if you want to say, I'm going to have it in East US, West US, South US, North Central US, and then the traffic manager does that work for you of figuring out what your closest Azure region is. Right? So this last slide is really another way to help you just decide, what do I need, right? I want to have a load balanced application. Do I need it to be load balanced geographically? Do I need it just to be load balanced within one region, right? Do I need all the features of application gateway, or can I just use the load balancer for free? What, you know, it's this kind of helps you decide there. All right, so we have a service called Azure DNS, and this is public DNS, right? So, you know, when you register your domain name and you put in all your CNAME and your all those rules, we have the same thing. So you can have your domain. We don't register domain names, but you could point your domain name name servers to us, and then we can handle all of the different records, right? So this is public DNS. It integrates with our management services, so you can access this via the portal, via our command line tools. You could also have it control to the DNS based on role-based access, so you can give different members of your team different permissions to managing the DNS. This is a pretty new service, and I put it here because I want to make a distinction between Azure DNS and private DNS. So private DNS is what you would use for DNS inside of your VNets. If you have VMs that want to talk to each other within a VNet, then they can, within the bounds of a single VNet, you don't have to set up any DNS, all right? And so I just want to also be careful with the terms. We have Azure Public DNS, which is for public domain names, and we have private DNS, which is for DNS of your local, VNet, all right? So if you're just having VMs talk to each other inside of a VNet, you don't really need to bring your own DNS solution. Any other situation you can see in this table where you're going to have VMs talk to VMs in other virtual networks or on networks that are on premises, that's where, and you want to be able to use the host name, resolution and all that, that's where you'll need to bring your own DNS. So using our DNS is easy. It's pre-configured. There's no configuration you have to do. It comes out of the box when you create a new VNet. There's some limitations, but if you do need your own DNS, you could set that up in Azure as well. So in Azure, we can have our VMs attached to the VNet with private IP addresses, and those could be static or dynamic. So if you create some kind of appliance or you need something in your virtual network to have a static IP, you can create that without a problem. The default is dynamically created, but you could also create static IP addresses as well. And you can associate those with VMs, with load balancers for the internal load balancer, and for the app gateway. So you can have an internal version of the app gateway as well. And then we have public and private IP addresses. So we have a limit of how many public IP addresses you can have. You can have 20 static public IP addresses. If you want more, we don't publish what the hard limit is. If you want more, it's a support request, and there might be more to that, but that is the published limit, and then it's basically, contact us if you need more. So dynamic public IP addresses, we don't know what the IP address is until we create an instance of that service that it's attached to. So until I create that VM, I don't know what the public IP address that I have associated with it, because it's dynamic. And then if that VM gets restarted or deallocated, when it comes back, it'll have a different public IP address. Static IP addresses do get provisioned right when I request a static IP, so I could attach it to different device, to a VM, to a load balancer. I can move it around, and I always have that until I actually shut off, until I delete that public IP address itself. All right, and then the last thing to talk about for network services is user-defined routes. So user-defined routes are what we talked about a little bit earlier, where I may, in my VNet, want the traffic to get routed through a virtual appliance or back to on-prem because I want to inspect all the packets. I have to do that for compliance reasons. That's where I can create my own route table for the subnet that those VMs are in, and have that traffic routed appropriately. And if I'm using a virtual appliance, I need to enable IP forwarding on that virtual appliance so that it can receive traffic that's actually destined for somewhere else, right? So that's an important thing to know, right? So these are the two main scenarios. That's why they're red, and turning on IP forwarding is important. And there's a nice animation for this that shows you kind of how this works. All right, so now I have about like 10 questions and answers, which kind of go through all the material we talked about, and I think it's useful to go through this to think about taking the exam, and as we explore some of these questions, we'll see why the wrong answers are wrong. Also puts you in the right framework for kind of understanding how we choose all this. So in this case, I want to let mobile workers connect to a VNet in Azure. What is the right solution? Anyone? Yes? Bingo, point to site, right? Yeah, so that makes the most sense, right? This one is, let's say you create a jump box in Azure, only allow users to SSH into it from their home or office. The jump box IP, private IP is 10.0.0.100. How should you configure the network security group rule? And for these types of questions, which you'll see, what I try to do is I look for things to disqualify an answer right away. So in answers 1 and 2, we see the direction is outbound, but we're talking about inbound, right? So now we're between 3 and 4, right? And if you look at 3, it says source address prefix, right? That's saying that's where I will allow traffic from, but I don't know where the traffic, that's an internal IP address range, right? So the answer is 4. That's how I would configure it. And I would attach it just to the jump box, not to the subnet that it's attached to. No, sorry. I would attach it just to the jump box, not to the subnet that the jump box is in. All right, so I'm updating an app to new release. I want to minimize downtime as much as possible and slowly introduce the release into production. Which traffic manager routing method should I use? Weighted, right? For the scenario I mentioned earlier. You've got an Azure VNet in Europe and one in North America. What is the most cost-effective way to connect these VNets so they can communicate securely? Actually, this is not fair because I didn't talk about one thing that I should have, which is VNet peering. Yeah, but VNet peering is the wrong answer because VNet peering lets you connect two VNets together when they're in the same Azure region. And this uses the Azure backbone, and so that's the most efficient way. But when they're in two different regions, they essentially have to be a VNet to VNet connection. You need a gateway, you need public IP addresses. They're essentially two different external VNets talking to each other over VPN. And you could connect with ExpressRoute or through your on-prem, but that wouldn't be cost effective. When adding a new VM to a load balancer, what must I do? This one's tricky. Right, the answer is, all I have to do is update the backend pool, right? I don't change distribution mode. That's that 5-tuple hash we talked about. I don't have to restart the load balancer. I don't need a new probe. The probes will find that new VM and request it in the backend pool. I have 25 IIS websites that I host in Azure. Each has separate domains. Some require HTTPS and some require cookie-based session affinity. At a minimum, what will I need? What is it? 2 app gateways. Yes. And this deck and all the questions are in the GitHub, so you can come back to this. I have VMs in 2 Azure VNets that I need to communicate via name resolution. What can I use? Any ideas? 1? Who said 1? 2? 3. Because they're in 2 different VNets, so that's inter-VNet communication. I can't use the private DNS for that. The Azure DNS service, that's just for public IP addresses. When you register your public domain names, you can create records for that. I need my own Azure-based DNS servers running in Azure, and I don't need to connect to on-prem because I don't mention on-prem in this solution here. No, as far as I know, you can't, unless you know different. Oh yeah. All right. I'll look into it and I'll let you know when we talk to next time. I'm going to talk to you again later for another part. I'll find the answer. Clients outside of Azure access my VM by IP address. I've maxed out my static public IP addresses for the subscription, and I occasionally need to turn off the VM. What is the most cost-effective alternative? Right. So here, they need to access this VM constantly by IP address. So I don't want the IP address to change, but I don't have any more public IP addresses to assign to it. And I can't use a dynamic one because if I shut the VM off, I'll get a new public IP address. So this one, 4, yeah. So this is a little trick, right? The load balancer, as long as the load balancer stays up, and that's essentially a free service, I'll have that public, even if it's a dynamic public IP, I'll have it associated with it. And I can just put the VM in one VM in its backend pool. All right, and that's it. I'll show you the labs here that I built. I have 2 labs. One is for creating VNet to VNet connections. This is one I authored, and this uses the command line tools. And Azure now, we've got the command line tool built right into the portal. I don't know if you guys have seen this, but the lab instructions assume that you'll use this. If you've got the command line installed somewhere else and want to use that, that's fine. But this is a really nice, simple way to get started with the command line tools. And then the other lab is pretty simple. It's point-to-site connection, and we have really good documentation on how to build that, right, step by step for how to do this. So what's nice about this is that you'll use the command line tools for building the network resources that you need. The lab for point-to-site will walk you through doing it in the portal, so you kind of get exposure to both with VNet, and with both those you'll see the gateways and connections, and you'll get a feel for how all that works. All right, so how are we doing on time? Wrap up. All right, so any questions for me? I know it was like a whole bunch of stuff that we talked about, but
you did not cover any of the paths and networking concepts around paths. Was that a separate topic or separate lecture?
yeah, so the question was, I didn't talk about any networking with paths. Is there a specific PaaS service you're thinking of?
So web app.
Right.
So web app as a public IP, and then how you maybe work with your IAM services or IAM.
Yeah. Yeah, so a web app, and there's a section later on web apps. They'll probably get into that more because that's focused. But with web apps, you have 2 options, right? You could build an application service environment, which is you define a virtual network, and we'll deploy the PaaS instances and the whole managed PaaS stuff inside that VNet. But then you can use that VNet to connect to ExpressRoute. So if your web app is a front end and your database is in your on-prem, and you want an ExpressRoute connection to minimize the latency for those requests, you could use application service environment. And the other option is if you just have a web app without app service environment. App service environment can be expensive, but you could also use a built-in point-to-site network connection between web apps and a virtual network. You can kind of achieve the same thing, but now it's just a point-to-site. So you can access those those resources via private IP address, but you don't get the benefits of being in that VNet directly. So there, and for every PaaS service, it's better to probably just talk about each individual PaaS service and networking implications, because we could talk about, just like we talked about Service Fabric, all those different things. But okay, sorry. Hybrid connection. What is it? Through it via networking. Yes. Yeah, so every service in Azure has some kind of hybrid gateway. So there's the Azure Service Bus relays that you're talking about. There's the Logic Apps connector, the Power BI Apps connector. There's like every service has some kind of hybrid, which is nice about Azure, right? Because every time we release some new cloud-based service, we always think, how can we connect this back to on-prem? I think we do that more than a lot of other, cloud providers. Any other questions? No, so how much time do we have? So I guess now would be time to start on the labs. We have what? Oh, yeah, they're all independent, yeah. The labs, so my first lab, which does VNet to VNet, when you walk through it, I just ask you to deploy the template, an Azure ARM template that I built. Creating the gateways in Azure is time consuming. It takes about a half hour to build up the gateway, because it's a device that has to get provisioned and has a public IP address. I don't know, there's a lot going on in the background for the gateways. So what I have you do in that lab is deploy the template right from the beginning with very minimal explanation. And then as the template is deploying, we can explore all the resources that get created. And then once the gateways are up and the connection is made, you can SSH directly from the cloud CLI that's in the browser. You can SSH into one machine, and then that's the one that will has a network security group on that allows you to SSH into it, and that's your jump box. And then you can SSH into another VM that's in your other region. You can SSH into that, and that has no network security group that allows external access, only from that jump box and from that VNet. So it kind of demonstrates the point. I create a jump box, and I can communicate across VNets in Azure to SSH into a specific VM on the other side. So, yeah, but you don't have to do it in order.